Good morning, students. So, last time we have completed till polymorphism. So, today we will start from hygroscopicity. So, basically, what is hygroscopicity? Uh, a, a hygroscopic substance is that absorb moisture, and moisture can be absorbed or uptaken by various methods. So coming to the definition, there are so many drugs substances like water soluble salts forms that have tendency to absorb atmospheric moisture that contains water. The adsorption and moisture content is also dependent on the humidity present in the atmosphere, temperature, surface area, exposure, and mechanism of moisture uptake. Now coming to the section that what are the degrees of hygroscopicity that are classified into four different classes. So first level of hygroscopicity is slightly hygroscopic. In this class, the increase in weight is more than 0.2%, but should be less than 2% weight by weight. The second level of hygroscopicity, the increase in weight should be more than 0.2% weight by weight, but it should be less than 15% weight by weight. Then coming to the third class of hygroscopicity, that is very hygroscopic. In this, the weight can increase more than 15% weight by weight. And in last level of hygroscopicity, it is daily quotient, that in this class the substance absorbs sufficient water to form solution. It is totally liquid form. Now coming to the how hygroscopicity is tested. The hygroscopicity is tested by three simple steps. The first one is samples are exposed to the moisture, then exposed to the controlled relative humidity environment, like everything temperature, pressure is controlled. Then coming to the third point, moisture uptake is monitored at different time points, like after half an hour, after 1 hour, after 1.5 hour. Likewise, we have to monitor. Now coming to the various analytical methods that are used to measure hygroscopicity. The first one is gravimetry method. In this method, it is like a quantitative method for accurately determining the amount of substance by selectively precipitation of the substance from an aqueous solution. Second method is Karl-Fischer titration. In this method, we perform titration that helps to determine the uh, trace or very minimum amount of water that is present in the sample or our drug. There is one more method for the measurement of hygroscopicity, that is gas chromatography. This we will not discuss in detail, just you remember the name of this method. Now coming to the powder characteristics. The powder consists of various characteristics. It comes in various sizes that also affect the solubility of the solution. Uh, Now definition is it is the most important characteristic of powders is their particle size, and depending on the size of particles that I have already told, these are classified as very coarse, coarse, moderately coarse, fine, very fine, and finally the size of particles can influence various factors like dissolution rate, uniform distribution, suspendibility, penetrability, and many more things. Uh, Now, coming to the methods that will help us to determine the particle size. The first method is sieving. Here we can measure particle size ranging from 5 micron to 150 micron. The second method is microscopy. Here we can measure particle size ranging from 0.2 micron to 100 micron. In third method, that is sedimentation rate method, here we can measure particles from size ranging 1 micron to 200 micron. The last method is light energy diffraction method. Here we can measure particles that are ranging from 0.5 micron to 500 micron. Here the light beam passes through the dispersed particulate sample. Uh, Here we have to remember one thing, like for larger particles light scatters at smaller angles, whereas in case of small particles light will scatter at large angles. uh, like for small one particles the angle will be greater, and for large particles the angle will get smaller. Now coming to the powder flow properties. The powder flow properties can be affected by change in particle size, shape and density of the particles. The flow properties of powder depends upon the following. The first one is force of friction. How much force is applied to the particles. Accordingly, the friction will either increase or decrease. The second is, what about the cohesion force that is being applied on the particles? But coming to one important thing that we have to remember, like fine particle possesses very poor flow because these fills the void spaces between the larger particles, causing packing and densification of the particles. To avoid this, we use gradient that can alter the flow properties or that can improve the flow properties. For example, talc is a very good gradient that enhance the flow properties of various powders. Now coming to the determination of powder flow properties. Here we measure several parameters like angle of repose, Cars index, and Hausner ratio, angle of repose, tap density, and bulk density. So first one is angle of repose. Here a greater angle of repose indicate very poor flow of the powder. It should be less than 30 degree and can be determined by the following equation. The equation is mentioned here, that is theta equal to tan inverse into h divided by r. Here theta is angle of repose, h is height of the pile, and the r is radius of that particular pile. Uh, Here you can see one table in which the values are mentioned, like for angle of repose in degree. If the angle of repose is less than 25 degree, then the type of flow is excellent. If the angle of repose is ranging from 25 degree to 30 degree, the type of flow is good. If the angle of repose is between 30 degree to 40 degree, the type of flow is passable, it can pass. And if the angle of repose is more than 40 degree, then the type of flow will be very poor. There are various methods to determine angle of repose, like just have to remember the name of these methods. First one is static angle of repose, fixed funnel method, fixed cone method, rotating cylinder method, tilting box method. Now coming to Cars index, it is the measurement of free flowing powder by compressibility. The formula for Cars index is tap density minus bulk density divided by tap density into 100. It is a very simple, fast and popular method for predicting powder flow characteristics. For this also, like same as angle of repose, in cars index there is one table for type of flow. If the cars index lies between 5 to 15, the type of flow will be excellent. If the cars index lies between 12 to 16, it will be good. If cars index lies between 18 to 21, it will be fair to pass. If the cars index lies between 23 to 35, the type of flow will be poor. If cars index lies between 33 to 38, it will be very poor. And if it is more than 40, it will be extremely poor. So we will now end this lecture. We will continue further in the next lecture. Thank you.